Hello and welcome to another lecture in CIT 130, Introduction to Java Programming. What we're going to be talking today about is something called exception handling. In programming, in particular in Java object-oriented programming, we have an architecture called exception handling. An exception is any event that is unexpected or exceptional within the running of your program. If you remember from when we've been working with the rectangle class up to this point, we have done data protection. We did two different kinds, or two different places with slightly different strategies for our data protection inside of this rectangle class. We didn't want height or width of a rectangle to ever be negative. So we, if a positive number was entered, we went ahead and assigned it. In the constructor, if a negative number was entered, we gave a default that would not be in line with the calling program's expectations, but which allowed the rectangle to still be created. Since it's a constructor, if we didn't do anything here, it would set the width to 0, but since we had the no argument constructor 1 by 1, we chose as part of our design to make it 1 by 1. But note that this may be different than what the person expected on the rectangle test side. Always think, an exercise you want to get in the habit of is thinking that the person writing the testing program that creates the objects from the class may be different than the person writing the objects, or writing the class itself. So this was one of the things we did was set it to 1. Inside of the set methods, which would be called on an already instantiated object of the class, we just did nothing. The rectangle itself will not change if they enter in an invalid value. Now what we're going to look at today is a new construct that allows us to manage or handle these exceptional events, data that's unexpected or not what we intended, in a way that's independent of the logic of the program itself, which separates the duties of identifying problems with how we handle them, so that the calling program will have the opportunity to decide what to do if an error occurs, but the designer of the object only has to decide when it's been an error. And we'll also see that we won't need to know exactly what creates an error or how it's defined, like width and height having to be positive numbers. Because right now, the way we're dealing with this, we had to test on both sides whether the height and width was greater than or less than 0, which means that the person who wrote the test and the person who wrote the object both needed to know where that erroneous behavior could happen. Exception handling is going to get us away from needing to do that as well. So we can see that it's going to be a much preferable way of dealing with these exceptional behaviors. So let's look at the simplest sense of this architecture first, by instead of putting in some default value when creating the rectangle, if instead we allow the calling program to make that decision when exceptional behavior occurs, we can introduce a new keyword called throw. And what we throw is a new object of one of the many exception classes that exist in the API. Illegal argument exception, as it sounds, means that one of the arguments that came into this method was illegal for this object. Therefore, we want to raise that as an error or an exception to the calling program to decide what to do with it. We can include a message, all rectangle objects must have a width and height of at least 0. So what we're doing is we're sending a special kind of object that is from a throwable class, and all exceptions are throwable classes. And we send that object back to the calling program, and it will be able to manage the error. Before we go on the other side and look at how to manage it, let's first see that changing that with legal data isn't going to cause any differences. Now, in the version of the rectangle test that we've been working with so far, we never used the send the height and the width version of the constructor. So let's go ahead and do that now. We'll save that. Let's make sure both are saved. Let's go ahead and let's compile both our rectangle.java and our rectangle test.java. And let's go ahead and run the rectangle test program. And what we're going to see is that now, instead of both the first and second rectangles being 1 by 1, the second rectangle is 3 by 5 because that's what I sent it. We didn't touch any of the rest of the program, so we'll just follow through there and come back in here. But what if a negative number is entered in there? Let me go ahead and save that. Let's recompile the rectangle test and let's rerun it. What we see is the program crashes and we get a message that says exception in thread main. Thread is just a fancy word for a running set of code. So an exception has occurred in the main method java.lang.illegal argument exception. It shows that message that I put in there. All rectangle objects must have a width and height of at least 0. And it shows that that error occurred originally in the rectangle object at line 49, but ultimately caused this program that we're running, rectangle test, to crash at line 20, which is where we called that. We saw that because we didn't choose to manage or handle the thrown exception. So let's do that. Whenever we want to call a method that might throw an exception, it's customary to put it inside of what we call a try block. The try header simply says that one or more lines of code inside this block may throw an exception. After a try block, we put in what is called a catch block. For a catch block, we specify what kind of exception we expect to be thrown, and we give it a local name because this is like an input or an argument back from the throw. When it throws the exception, the illegal argument exception, and we catch it, we have to give it a local name. We typically use the capital letters from the exception type, so IAE, illegal argument exception, as the local name. And then we decide what we want to do with that. What I'm going to do is I am going to print out the message from that exception, IAE dot get message. The message is a property of the exception. So if we get the message that we set at construction time of the thrown exception, we can display that out. So what we see here is that now when this error occurs, what we're going to do is we're going to handle it by catching the thrown exception. We're going to print out the message. Now I want to do one more thing here. I want to, instead of not having an R2, I want to set R2 to the base rectangle, which will be the one that's 1 by 1. Now note, because of scope rules, R2 only lives in this try method. So what we actually want to do here is we want to create the rectangle R2 at the beginning of the main method like we were before, but we want to try to instantiate it in the try method. This allows the scope of R2 to remain the same, so we can print it out and such down here. But we still have the opportunity to try to instantiate it. So when we try to instantiate it, if it doesn't work, which it won't in this case, we'll catch the exception, print a message, and we've decided, not the designer of the rectangle, to create the 1 by 1 rectangle instead. And I can also go ahead and add to what the user sees. I could say a basic 1 by 1 rectangle will be created instead. So we're adding to the message that was passed back to us and let the user know what's going to actually happen here. Let's save that. We've only changed rectangle test. So let's compile that. Oh, I left out my semicolon on the end of my print statement. Rectangle test. Oh, I didn't save. Goodness. Let's go ahead and try one more time. Now it compiles. Let's go ahead and run it. Now you'll see, instead of crashing like it did above, we see the message from the exception. All rectangle objects must have a width and height of at least 0. We also see that extra message we sent, a basic 1 by 1 triangle will be created instead. And we see the R2 is a 1 by 1. We didn't change anything else. We'll go ahead and finish off the code that or the program, because we didn't change anything else. So the basic use of exceptions is when the behavior occurs in a method, we throw an exception to the caller, to the method that called, or to the code that called this method. On the other side, when we call the method that can possibly throw an exception, we put it in a try block, and we follow that try block with a catch that specifically looks for the kind of exception thrown and decides what to do with it. In this case, we've decided to print the message, give the user some extra information that indicates to them that R2 will be created as a basic rectangle, because otherwise things like this printing out of the rectangle below wouldn't even occur. So in order to maintain the integrity of this rectangle test, we'll do it this way. And what's awesome is if we go back to the one that doesn't, with no mistake, and we run that, we'll see that we don't get those messages, and the program just runs as we would expect it to run. We'll go ahead, fill in the rest. We haven't changed any of that code. Now, typically, we wouldn't need a try and catch statement here. We saw it run without me doing it, because we normally aren't going to call a constructor with bad data. We knew what we were doing. We wouldn't have made that mistake. So but this showed the simplest version of how this architecture works. The throw happens here. The try calls the method that throws. The catch decides what to do if it occurs. One thing that you may be asking is, well, if I know that it's not going to occur, do I need to do this? Clearly you don't. I showed you that we didn't. That's because illegal argument exception falls into a category of exceptions called unchecked, which means we may choose to try and catch with it to handle the exception, or we can choose not to. I explained in much more detail in the advanced Java class what the difference between checked and unchecked exceptions, so come back next term to get those details. For now, we're just going to go ahead and manage these exceptions so that you can see how it works and you can apply it to your own coding. So before we move on to looking at another aspect, I want to come back in here, and now that we are not doing the automatic setting of the width or the height in the constructor, we can think again about calling the set methods from the constructor rather than doing it this way. What we'll have to do, which we're going to have to do anyway, is let's do the exception handling down here in these two methods. The reason I say we're going to have to do it anyway is, again, the best practice is when an exceptional behavior can occur, we want the calling program to be able to decide what to do. What we had done before is nothing. If the exceptional behavior occurred, we did nothing on this side. Now we're throwing an exception to allow the rectangle test to decide what to do with it. But now that we're doing that, the code up here would look identical to the code in the two sets. So we have now we can just go ahead and call those methods instead of repeating the code. So we see an extra benefit here of properly handling exceptional behavior. Allows me to do it in the sets so that in my constructor that sets both properties, we just call the two sets, handle the exceptions there. And then out here in rectangle test, it can make the decision on what to do. Let me resave rectangle. We'll recompile rectangle. Whenever I recompile a class, I always like to recompile the program that depends on that class just to be on the safe side. I don't have to do that, but I choose to. And let's go ahead and rerun it. We'll see that everything's fine because the height and width were set properly in the rectangle test. And if we go back to the version where we improperly set it with a negative number, we'll see it's going to handle the exception in exactly the same way. I just moved the handling of the exception into the set methods rather than into the constructor. But in either case, we're allowing the calling program to make the decision on what to do with it. Now, one of the things that's happening here is now we've moved that handling, as I just said. The rectangle constructor calls a method which throws the illegal argument exceptions. Either of these sets may be the ones that are throwing it. So our instincts tell us, oh, well, I probably should do the try and catch up here. But since I still want that handling to be on the main program side, I want to, instead of trying and catching them, I want to hand it on. I don't want to manage the exception myself. I want to pass it through. With unchecked exceptions, that happens automatically. With checked exceptions, again, don't worry about how to tell the difference or when one is used or the other. We would have to do what I'm about to do, but I recommend you do it in either case, which means you wouldn't have to know the difference between a checked and unchecked exception. What I will do is when I know that this method may receive an illegal argument exception, what I can do is use a very similar but different keyword called throws to pass that illegal argument exception up to my caller. So I called something that may send me one of these illegal argument exceptions, and if they does, I want to pass it on. So that is normally how we would do that for best practices. So I go ahead and put that code on there. Again, we will see that isn't going to make any difference to the way this code runs. But again, if we want to use exceptions in the best possible way, and assuming that we want to go on to use our coding practices professionally, we want to follow those best practices. Let's see how that works. We still had the exception handled in the same way. We get the 1x1 rectangle, and everything works properly. So let's look at something else now. Like I said, in here, this is unlikely to, we're unlikely to, call this rectangle in a bad way. But again, the try and catch is a possibility. If this throws an exception, we catch it and do stuff. If it doesn't, it's as if that never happened. Again, exceptions separate the logic of handling the error from the logic of the program. So the program expects this to run. If it doesn't, we've built something over and above that logic to handle it. But let's look at it in the place where the user is entering the data, like down here in these do loops. This is where it will be a little more understandable on how this is going to work. Remember, the user could send the width as a negative number, but we check that inside the class, inside the object itself. It's checking for that. Why should we have to check that or even know that we have to check that to tell the user something? Instead, if it's handled in the class as it should be, really all we have to do is try and set the width. If I pull this out and do it right after calling the next double, but I put that in a try statement, whoops, I have now I no longer have to do this because my exception is going to send me the message as long as I catch it. Illegal argument exception, IAE. And what I can do here is I can print out system.out.println. IAE.getMessage, just like I did above. I'm not handling it any different, but I still need to check this, set this good data to false, because if I caught an exception, if the exceptional behavior occurred, I want to re-loop, give them a chance to try again. So what I did now is I tried to set the width. If the user entered in a bad value, the object itself, the rectangle object itself, will throw the exception. I can print the message and set good data to false, which will allow me to redo the loop. But now I no longer have to know how the class designed when that illegal argument exception is going to come, only that it will come. And in a minute, when I show you how next double can also throw an exception, you'll see how we would know what it throws without having to know the implementation. So in this case, I actually don't even need this else, because basically, if it happens properly, the catch never fires, the loop's over, and we move on. Let's see that work. That is just in the rectangle test because rectangle was already updated. Let's run it. And if I try to type in that negative number, what you'll see is all rectangle objects must have a width and height of at least 0, and I have the opportunity to re-enter in the width. So I put in something for the height, and everything works properly. Again, that's because when I got to this do loop, I set good data to true, I asked the user for the value, I took that value in, and then I tried to set the width of the rectangle. When the rectangle got a bad value, it threw an illegal argument exception, which then forced the catch to print out the message from the exception and set good data to false, which made the loop go around again. I can take this same piece here and put it over here. Control V. That's my catch. I don't need this. I can go ahead and take this and put it inside my try. And now they look the same. We take the next double off the keyboard, try to call the method. If the method is unsuccessful because the value entered by the user is a negative number, we print the message, we loop back around. Let's see that that works for us. I put in a negative number for the width. I get to do it again. I put in a negative number for the height. I get to do it again. And I get the results that we would expect. So that shows how this all works with handling exceptions when we write that code. But what if the user doesn't enter in a double here? And we can see what happens if I go out here and I type in a string. The program crashes just like it did before we had exception handling with the illegal argument exception. But we see here the exception in thread main is on an input mismatch exception. Again, looking at what we call the stack of code, that the scanner on line 939, which we didn't write scanner, is actually where that was through the exception to a line 1594 inside a scanner, which went to the next double on line 2564, which then threw that up, and this is probably did those throws in each of the methods up to where I called the next double on line 54 of rectangle test. So if I take this height and instead put it here, and I take this width and I instead put it here, what I wind up with is now, if an exception's thrown, I can catch it. But you'll have noticed that is an input mismatch exception instead of an illegal argument exception, because we called it an illegal argument because it was the right type but a bad value. When we put in a bad type, we call it an input mismatch exception. Now, there's no golden rules on which exceptions to pick. You just generally pick what you feel is conveys the idea of what the exceptional behavior is. But we do have the option for multiple exception types. We can catch more than one kind of exception after a try. It works very similarly to the switch statements we learned about, where it'll just find the first one that matches what was thrown. So in this case, when the input mismatch is thrown, the try will see it's not an illegal argument exception. Oh, but it is an input mismatch exception, and do whatever I tell it there. So let's try doing the same thing. System.out.println IME.getMessage. And we'll still want to set good data to false, because remember, they'll still need to re-enter the value. So let's see what happens there. Remember, we didn't write the code that throws the input mismatch exception. That's it, part of the scanner code. Let's compile. Oop. We cannot find symbol input mismatch exception. What you'll see is, if I go over here to next double, which is how I knew it was an input mismatch exception, by the way. If you wondered, how do you know what it throws? Inside, java.util, where scanner is, we've looked at that before, the next double has this thing that shows what exceptions it might throw. Now, the no such element and illegal state, those don't apply when we're using scanners with keyboards. In the lecture after the next one, when we do file input output, we'll talk a little bit more about these kinds of exceptions. But when we see that next double throws an input mismatch exception, I go over to it. Oh, I see that the input mismatch exception comes from java.util, not java.lang, which means I have to import it. I'm already importing scanner from util. So let me now import everything, which just basically when I put star gives me access to anything in java.util. And then I document what we're using. This gives us access to the scanner class and the input mismatch exception. And like I said, an exception is just a class that is throwable. It's still a class. We still use the new to create objects from it, and so on and so forth. So that will get rid of that mistake. Now let's see what happens when we run it. We have the opportunity here to enter a new width. So let's put in a word. Remember, the negative numbers we already saw, that's going to be handled properly. But what happens when I just put in words? Before, the program crashed because we had an unhandled exception. What's going to happen this time? That's strange. It keeps asking us to enter in the width again with the word null afterwards. Let's scroll up a little bit, and what you'll see is that before it started doing that over and over again, is it just printed null by itself. Remember, we asked it to print the message for the illegal argument exception. What it did is it printed the word null. That means that whoever wrote the scanner class didn't give us a default message. So I guess I'm not in a good position to print the message from IME. I'm going to just have to give my own message. And what I'll put in is, please enter in a valid number. That will tell the user what they need to know, since we didn't get that from from the exception itself. The person who threw that exception didn't put a message in there, so we got the word null. Now that's not going to fix that looping or that repetitive asking for the thing, but let's at least see that it's going to change null to a nice error message we can read. I put in text, and now I see please enter in a valid number. So what is happening here? If you remember from quite some time back when we were first working with keyboard input and strings and things like that, way back in our movie theater example, we talked about how the next methods like next double, next int, and next by itself return the next token but leave the carriage return from hitting the enter key in the keyboard buffer. So when the next double here happens, what it did was it took the text I wrote in there, which I think was like YY in this most recent version. Yeah, it took that YY off the keyboard buffer, but the \n was still there. When I sent YY, so when it took that YY and tried to use it as a double, it threw the exception. We caught that exception, printed this message, good data was false, so we looped back around. It set good data to true and asked the question again. But the problem is immediately it goes back into the try and tries to grab the next token, which is the return key. That's not a double. It throws the exception again, and that's infinite because these nexts never consume the carriage return. What we learned back in when we first did this was we follow a next double or next int or next that is gonna eventually use something where the return key may get in the way. We put in this extra next line, which takes everything out of the keyboard buffer, including the carriage return, so that we won't have that infiniteness. But there's a thing we have to keep in mind here. With exceptions, as the line that throws the exception interrupts execution. So when next double throws an exception, it no longer runs any code within that same block. All of this does not run. It jumps directly to the catch, and we'd still have the same problem, because I'd never get to that keyboard next line. What I need to do is put that in my exception handler. So now, if they put in something other than a double, it gets rid of the carriage return, prints out a message, sets good data to false, loops back around, and allows them to try again. Now, one of the things you'll see here, which is now really cool, because I wasn't able to use getMessage, and I needed to consume the carriage return, one of the advantages of having multiple catches after a single try is the logic of the program is take the number off the keyboard, set the width. If the expected behavior occurs, nothing else happens. But if exceptional behavior occurs, this architecture I wrap it in, which is independent of the logic of the basic program, manages that process, and I can do different things in different catch blocks. I don't have to handle every exception in exactly the same way. With the illegal argument exception, I don't need to remove the carriage return, but with the input mismatch, I do. So I only execute the code that's necessary when I manage those exceptions. So let's make sure we have everything matching. I think all we need to do is grab the keyboard.next line and add it into the input mismatch down here along in the height one as we did in the width one. So let's go ahead. Let's save that work. Let's recompile. Let's rerun. I put in a word like 3. Please enter a valid number. That's the second catch taking effect. I put in -5. The first catch goes into effect. When the second catch went, it got rid of the carriage return, printed this message, set that Boolean variable so we would repeat. When this happens, the first one fires. We do not get rid of the carriage return. We print out a message and we set the Boolean to false, so we loop back around. When I put in a valid value, expected behavior occurs, no exception is thrown, no catch code happens. I can do the same thing with height. I forgot to apparently get rid of, put my message in there, so I'm still seeing the null. We'll go back and fix that, but I put in the negative number. That kind of went funky on me, I think, because of, not sure. Let's see if it, I think because I didn't match things somewhere, it's firing. Let's take a look at the code. Both of them have the next line. Let's go ahead and copy that and put it in here in the input mismatch. I think everything matches now. Oh, I had put the wrong message in there. So it was working correctly. What I had done, the reason we got the null, is I did my copy and paste the first time incorrectly. So what I actually had done, I hadn't forgotten to copy my message down. I just copied it into the wrong place. So what was happening is I was getting the enter a valid number with the illegal argument exception, which I didn't want, and I was getting null with the input mismatch exception, which is also what I didn't want. Now I fixed that, and we are back to good stuff. I'm certain that worked, but let's just go ahead and test. You always want to test any changes you make, regardless of your confidence level. Nothing is more embarrassing than sending code out to independent testers, or worse yet, to end users that has silly mistakes that you were confident wouldn't occur. So let's go ahead and do it. 3, enter in a valid number. Well, here's a valid number, but it must be at least 0. Let's enter in 3.2, because remember it is a float. With the height, I can put in stuff. Please enter in a valid number. Well, I'll give you -6.4. Oops. It is, that's still an invalid number because I put an extra decimal in there. must be at least 0. There's an example of where exceptions are really good. That was a legitimate typing error by the user that the exception caught properly. Really good stuff there. So now enter in a valid height. We'll do 6.1, and now we got that all nicely handled. So it's 3.2, 6.1. We get the area and the thing. The copy constructor worked as expected. Our exceptions all got handled. So, reviewing what we did today, we looked at exception handling. An exception is any behavior that occurs in a program that isn't the expected or anticipated behavior. What we're doing in this case, up in our first version, up here, is in the one we wrote, is we expect the number to be 0 or greater. If it's not, we allow the calling program to decide what to do with the exceptional behavior by throwing a new object of some exception type. We chose illegal argument exception because what we're saying is the argument passed in had an illegal value. There's no magic to which exceptions to choose. Just select based on your gut instinct. You can give a message to an exception, as you saw with the input mismatch. You do not have to. When that exception is getting passed to, I did that in the wrong place. I see now. When that exception is not going to be handled in the calling method as we did here, you can pass it to the next caller by using the throws and the exception type. We did that here so that it went to the rectangle test. Up at the top, when we called this new rectangle with a negative number, it called this constructor, which called the set, which threw the exception that we threw back, which means this line interrupted, and we went to the corresponding catch statement where we printed the message, printed something additional, still created a rectangle, but one that didn't have illegal values in it, and the program went on. The exception handling allowed the program to continue even though errors had occurred. We additionally handled errors down here with user input by taking what they typed in off the keyboard. If it wasn't numeric, we had one catch statement to handle that. If it was numeric but was an illegal value for a rectangle, we had a different catch statement that handled that. We did it in both places just like we did before, so that if the user has a problem with width, they're only dealing with width, and then if they get the width right and have a problem with height, they don't have to go back and re-enter width in. That's why we did this. We kind of repeated the code. This is a place where it's because we were having different things occurring in there. So we separated them into their own loops. We talked about that previously in a previous lecture with the rectangle. But note that either way, Either one of these lines can produce an exception, so we can put them in a single try and have multiple catches. The appropriate catch is the one that gets called because it finds the one that matches whatever came back. And remember, the benefit here is the program continues to run rather than crash when the exceptional behavior occurs. And additionally, we see that this wrapper stuff, the try and catch stuff, is independent of the logic for when it goes as expected. The person enters in a number, and that number is 0 or more. The logic for handling the error is wrapped around the logic of the program. We can keep those ideas independent of one another, which is what makes exception handling so nice. So we will be revisiting this again. We have 2 more lectures in this course, one on static members and one on data, working with data from text files. Particularly when we're working with the text files, we'll be revisiting exceptions again, so you'll get another new example that will be different than what you've seen here. As always, if you have any questions, please reach out to me. Otherwise, enjoy working with exceptions in the latest homework. Take care. Bye.